Hey folks, we are still on the road and broadcasting from sunny and very swampy Austin, Texas. And today we have a conversation with Steve Koonin, who a couple years ago wrote a book called Unsettled, which is all about the fact that despite reports, the science of climate is not a done deal. There are still a lot of open questions, and depending on how you look at the data, perhaps the overwhelming alarm that we experience coming at us from all directions is unwarranted.
Not only that, but it might be working against our best interests, and particularly if we're concerned about the environment in so much as our well-being is part of our environment. And it's probably worth saying that the climate is changing, and that is not what this podcast is going to be about. You know, 10,000 years ago, the Earth was a very different place than it is today. And there's all sorts of interesting cycles. There's so many factors that go into determining the temperature of this rock. And we're not disputing that. What we're trying to figure out is whether this is going to lead to the catastrophic doom that's driving a lot of the policy in our country and around the world today.
And more specifically, what better policy would look like. I've mentioned on the show before, and I mentioned in this episode, that I'm like, look, human societies have decided that things are going badly for them and done all kinds of crazy things through history. Like, we know that civilizations face difficult conditions and then just start doing irrational things that they hope will change their future. And the things they're doing are either dysfunctional or not effective or actively working against them. And in order for our civilization to survive, we need to make sure that the decisions that we're making politically, socially, and culturally are decisions that are going to have the desired outcomes. And because Steve Koonin has worked in the academy, he's actually a computational physicist by training. He's worked for BP, so he's worked inside the industry. He's now a professor at NYU. He worked for the Obama administration. He has this holistic perspective on how all of these different systems fit together and where to apply perhaps positive pressure, because I think everybody's in agreement that we need to have a clean environment. We need to take care of the environment, but that doesn't just mean like a nice wilderness area outside of some expensive coastal city. It means actually taking care of the 8 billion people in the world so that they're not living without electricity, so they're not cooking their food on indoor fires and dying 20, 30 years too early because of the fact that their environment is so polluted. And it's hard to think about those things.
And there's no reason to look at the relationship with our environment as a zero-sum game. It's not us versus them. There's a way to move forward where everybody benefits, literally everybody, not just a few people who can go into the woods for vacation periodically.
Yeah, and so it's really a question of, okay, well, what are the interventions that seem plausible? How did we come to the point that everybody's so hysterical? What are the pieces that are worth being really worried about? What are the pieces that are probably not worth worrying about? What predictions are realistic? What predictions aren't realistic? We do a little bit of kind of technical stuff about climate models at the beginning. We have a lot of philosophical and social questions, and I think we cover a lot of ground that's going to help us in all the future conversations that we're going to have on this subject.
And I did want to make a disclaimer because I know some of you hear that this guy was a BP exec, and your first thought is like, oh, well, you can't trust anything this guy says. But what's kind of interesting is he wasn't in any way related to the actual profit structure of BP. He was just there to propose what sorts of technologies would be necessary if this zero carbon dream came true. And it's actually the exact same job that the Obama administration wanted him for. And so it's a wide-ranging scientific career rather than, he took a stint over at BP to buy a few extra lake houses or something like that. I think that would be a misread of the situation. So hear him out.
And before we get to the conversation, as always, a reminder, if you like what we do and you like the podcast, support us on Patreon. We can no longer plug the conference because it has just gone off. And I want to take the moment to say that it was absolutely incredible. We have the most amazing audience. Everybody is super interesting and warm and friendly, and they come from all corners of the world, all different professional backgrounds, all different.
Different cultural backgrounds. I couldn't believe how different everybody was, other than the fact that they're all interested in understanding how the universe works. It was just a remarkable, rich crew of people, and everybody came together and helped make the conference happen, helped clean up after the conference. It was just absolutely heartwarming view on what people are capable of when they
Yeah.
come together over a shared curiosity. So thank you to everybody who was there, and thank you to our patrons for making the show happen and keeping us amped about what comes next on the program.
Shiloh's not ready to talk about this, but Demysticon 2025 is coming.
It's
Maybe
coming.
2026. So if you have suggestions for what that could look like, where we could hold it, people that we should invite to speak, let us know. Join us on our Patreon. You get both episodes early. You get them on Saturday instead of having to wait until Sunday and Thursday. And you get to join our patron chat, where you get to join our absolutely incredible community of supporters. So come on over to patreon.com, and hopefully we'll see you there.
The scientific revolution starts now.
Podcast.
Let us see in the dark.
Okay, that's my backyard in Cold Spring, New York.
I love it. Yeah, it's a good reminder that we're all in love with the greenery.
Yeah.
And I feel like these climate discussions can confuse people into thinking there's some side that's opposed to actually having a beautiful planet, which I think is
Right.
kind of silly.
Right, exactly.
One thing that's really, really confusing to us is the history of the modern climate change story, the picture, and how that all got started. We got a little bit of a sense in our conversation with Richard Lindzen, who was essentially blaming it on the academics having access to the energy sector's enormous budget for the first time, and sort of this something of, I don't want to use the word tumor, that's too derisive, but some sort of growth happened.
A benign growth.
A benign growth, I don't know how benign it is, inside of certain sectors of the academy that had never been given money in the past, like atmospheric sciences, things like this.
Yeah,
All of a sudden, it was a real gold pot. But
right.
I'm not sure that that's the whole story. So I was wondering if
And I'm not sure I can shed too much light on that. I mean, I was not there at the beginning. I really first jumped into this in about 2000 or so.
And so do you have any insight on, the 1950s where this was first becoming an issue?
No, this was well before my time.
Okay.
Well, what did it look
so I'm
like when you
afraid I
first?
can't help it.
Yeah, that's fine. I mean,
Yeah,
what did it look like when you
we
first
talk
showed
about
up?
how I showed up, right? And so, are we recording?
Yeah, we're going.
Yeah, good. Okay, good.
Hey, what was the temperature? What was the temperature of the room, so to speak?
Yeah. So, I was working with a group called Jason, which is a group of scientists, engineers, used to be mostly physicists, but now is broadened out to include biologists, information scientists, earth scientists, and so on. It was a group that was started to repair in the 60s, late 60s, to repair the schism that had developed between academia and the national security part of the government because of the Vietnam War.
Hmm.
So maybe it was a little later than the 60s that it got started. And it considered about 50 scientists, and we do studies only for the government. Most of them are about classified work, intelligence, nuclear weapons, you name it. We still continue to this day. But in the late 90s, we had a connection with one of the DOE offices who portfolio included climate. It was actually both climate and the human genome, probably the most exciting portfolio in science and the government at that time. And the guy who was managing it at the time, Harry Petrinos, a good friend.
Hold on one
has
second.
since
I'm sorry. The
Yeah.
DOE was managing the genomes project?
Yeah, the
Yeah.
DOE managed,
That's-
co-managed, all right? It was NIH and DOE, NIH and DOE together.
what
But you can actually, why? How did that happen?
But yeah,
right?
what interest does the DOE have
Yeah.
in biology?
Well, for two reasons. The DOE had long had a genetics interest from radiation damage to biological systems. It had thousands or maybe hundreds of thousands of colonies of mice to study the effects of ionizing radiation.
Hmm.
So that was one reason. The second reason was the Human Genome Project was a big coordinated scientific effort of the kind that the DOE was quite experienced in, and the NIH had essentially zero experience in. And so it was managed as a partnership.
That's surprising that the NIH would have no experience. I assume they encompass epidemiology as well.
Yeah, but biology was and largely still is a cottage industry where individual investigators do their thing.
And the
This
Human Genome
required
Project was like thousands of laboratories that needed to be
right,
coordinated.
all working together. You do this section on that chromosome, you do that section. We put it all together in some central database, et cetera, et cetera. It required a lot more management and coordination than the biologists were used to.
That makes sense.
Okay, now what brought them into the climate discussion? How did they end up taking on that project?
The DOE.
Yeah.
So the DOE, one of the most underappreciated agencies in the Washington firmament,
The zoo.
is the largest funder of physical sciences in the government, bigger than NSF, very bigger than NSF. And its activities, which used to nominally report to me, range everything from material science to biology, as we just talked about, in particular, non-human, non-plant biology, namely microbial biology, climate, advanced supercomputing, plasma physics for energy, and so on. The climate program is there largely because of their computing expertise. In the nuclear weapons part of the DOE, there is a 70-year history of pushing the forefronts of simulation in service of understanding nuclear weapons. And when you think about what it takes to understand a nuclear weapon, it's about the flow of matter and radiation. And climate is largely that. It's not only, but largely that. And so there's a natural affinity from the folks who model nuclear weapons to the folks who model climate. And that's why you find first-class climate modeling in Livermore, PNNL, Los Alamos, a number of other places. NASA, of course, has its own, and it's good that there are multiples because the answers are not certain. And so that's why the DOE was in that business.
That's fascinating.
Okay. So this is still like kind of late 90s. And the DOE brought projects or questions to Jason and asked us to opine, answer. And there were two questions relevant to climate that kind of got me interested in the subject. The first was, did I say it's about 1990, 1991. The first was massively parallel computers were just coming on the scene. So remember that these are computers with These days, hundreds of thousands of independent nodes that can process information, crunch numbers simultaneously. And the question was, how could the climate models be adapted to that computer architecture? And how much better could you do? And the second question, and then I'll tell you how it affected me personally. The second question was small satellites, which are now pretty commonplace, right? Mr. Musk wants 50 at a time or something. Small satellites were just coming into technical possibility. And the question was, what could you do with Earth observations using small satellites? And in the course of those two studies, and I think I led both of them, but I don't remember exactly, I got exposed to the science and the scientists and the community in a way that was kind of a crash education in climate science and simulation. Of course, I was familiar with simulation from my previous academic life and some exposure to the nuclear weapons.
Did you sense there was just pure fascination and curiosity with simulation technology, and that was the driving motivation, or was there this sense of we are going to save the world by protecting the climate?
No, these were not save the world type climate scientists. Okay, these were people who try to do science. All right, can we observe? Can we model? Can we understand?
And your background is computational physics, right?
Yeah, I spent a lot of my research time, doing large scale computations for quantum many-body theory, so on, nuclear physics. And so I got exposed to all these folks. It was great. And it started an offshoot science project, which might be interesting for people to hear about a little bit, that I took up myself. And it was a spin-off from the small satellite question. One of the things that you do with satellites is to measure the Earth's albedo, which is the fraction of the sunlight reflected from the Earth, or conversely, the fraction of sunlight absorbed by the Earth. And that sunlight absorbed by the Earth eventually gets turned into heat and is radiated back into space as infrared radiation. And the balance between the sunlight absorbed and the heat radiated out sets the temperature of the planet. It turns out that the albedo, the fraction reflected, which is 1 minus the fraction absorbed, is about 0.30 as measured by satellites. And if it were 0.31, so a little bit more was reflected, a little bit less absorbed, that would counteract all of the warming that is alleged to be caused by greenhouse gases. In other words, the temperature of the Earth is very sensitive to the albedo, and you want to know it precisely.
And is this thought to drive the glaciation cycles to some extent as you get
the glaciation cycles certainly affect the albedo. I mean, there's a feedback involved.
That's what I was
right?
saying. Mm-hmm.
Yeah, if the Earth becomes more ice covered, it'll be colder, and there's kind of a feedback like that, and it can run away, and you get what's called snowball Earth a long time ago in the past. So you need to know the albedo real sensitively, precisely, and how it changes with time.
It seems like it would be very different for different surfaces across the Earth. Right?
It is. And part of the problem that the satellites have. So you measure it with satellites. How do you measure it with satellites? Satellite goes around in a low Earth orbit, 500 miles up, and it's looking down at a patch of the surface. There might be clouds in the way, so on. The sun is off at some other angle, right? And the sunlight's coming down, hitting the patch, and it's reflected back to the satellite. So you got to know the geometry, and you have to know the reflectivity of the patch, and in particular, its angular dependence as well in order to say what the albedo is of that patch, and then you have to add it up over all the patches of the Earth. It's not a trivial problem.
Seems like the clouds and weather too would be hyper variable.
So you have to know what the clouds are. The satellite's got another instrument that measures the cloud, the extent of cloudiness, and so on. Not so easy. So we looked at that. And one of the old timers in Jason, a guy named Gordon MacDonald, who's since passed away, said, the way the albedo was first measured was by looking at the Earth shine. And of course I said, what's that? And went to look up the old measurements. And the phenomenon is that when you look at the moon, and the moon is a thin crescent, you can often see the rest of the lunar disk very faintly. And that light is sunlight that has been reflected from the Earth, goes up to the moon, and is illuminated by, is reflected by the lunar surface. And it turns out, if you think about the geometry for a minute, if the moon were close to Nu, so a thin crescent, and you were standing on the dark part of the moon and looking back at the Earth, you would see an almost full Earth. And so that averages over a very large portion of the Earth's surface all at once. It would be like if you had a camera on the surface of the moon looking back at the Earth. And
that's clever.
It is very clever, right? I didn't invent it. It was first realized by this French astronomer, André Danjon, and did observations very cleverly in the late 20s, early 30s.
Is it sensitive to infrared as well?
No, it's just the visible light. I mean, that's all we see is the visible light.
But the idea is that the visible light should, in some sense, account for other wavelengths as well as a proxy.
The reflected visible light is the complement of the absorbed visible light on the Earth, and that in turn determines the infrared. By the planet isn't gaining or losing energy nearly.
Got it.
And so Danjon did this by eye. He had a very clever instrument in which he measured the intensity, or he observed the intensity of a spot on the dark side of the disk and compared it to the intensity of a spot on the bright side of the disk in the crescent. Because the intensities differ typically by 10 to the fifth, he had to put a strong filter over the bright side and then used his eye to dial an adjustable filter so that the two patches appeared to be equal. And then he could infer the intensity of the earthshine. It turns out, after many decades of measurements, he documented the variability of the earthshine. It changes as the Earth rotates. The oceans are darker than the land. The clouds change, come and go. But he got the wrong answer about 0.4 for the albedo. And it remained a mystery about why it was the wrong answer. And Gordon MacDonald and I figured out why he got the wrong answer. It's got to do with some reflection property of the lunar surface. And when you made a correction for that, it comes out to about 0.3. That motivated me to enlist some friends who could actually do astronomy. I'm just a theoretical guy. I can't do it for that. To start a program in 1995 to do regular observations of the earthshine. And that program ran for 20 years, is still running. And what we found was the albedo was going down by a climatologically significant amount. So this is a pretty cheap way of doing whole Earth observations. It's a 5-inch telescope and PC and one observer and so on, compared to the satellite guys who need hundreds of millions every year to keep the thing running, the data analyzed. They're much more precise than we are, but it's a good check.
And in this condition, the variable radiation that's coming from the sun is accounted for because you're just comparing the amount of radiance on the
Yeah,
lit side of the
yeah.
moon versus the
It's
reflection.
it's a measurement of ratios, and
Yeah,
so
yeah.
the sunlight intensity cancels
Okay.
out. Transmission through the atmosphere largely, but not entirely, cancels out. So it's a really clever way.
So if you started this in the late 90s, if I remember
Yep.
correctly, like 97 was a really big El Nino year, and so would have
Yeah.
been really
Yeah.
high albedo when you started. And so do you guys think that it has to do with just the natural weather cycles changing
Well,
over time?
I mean, you certainly see that. I don't remember whether 97 looked particularly anomalous or not, but what you do see is a secular decline over 2 decades.
So the Earth is
Correspond.
getting less reflective over the
That's
course of
right.
20
It's
years.
called the global dimming. Some people call it. The Earth is getting a bit darker, or it's absorbing more shortwave radiation, sunlight.
And
We were,
do you have a sense for why that is?
yeah, maybe. Okay. We were very gratified, first of all, when the satellite guys, who had initially, when we started, blown off the measurement, you'll never get anything accurate or useful out of that. They came out a couple of years ago saying, hey, it's getting dimmer. Here's the data. And they sort of agreed. All right. So I feel vindicated a bit by that.
All right.
And we don't know exactly why. One of the hypotheses is that we've gradually been cleaning up the diesel or motor fuel that's used in ships. And that has reduced the aerosols and therefore made the reflectivity a little bit less.
Is reforestation any contributor to this?
And certainly people try to put that sort of thing into the models as well. As usual, it's difficult to untangle multiple
So what you're saying is
causes.
basically that global warming is caused by cleaning up the air.
Well, possibly. Okay. And again, I'll tell an anecdote if you want. I get to BP in 2004 or 5, and I'm starting to learn the energy business. Had been exposed to some of the climate business. And BP is saying natural gas is going to be a bridge to the clean energy future. And you still hear that, not only from BP, from many other people. And I sat down and did back of the envelope calculation, literally back of the envelope, about if you swapped out coal and the aerosols that coal produces and replaced it by gas, which emits less CO2, but no aerosols, the net effect for a long time is actually warming rather than cooling. And you got to wait a long time before you have reduced enough CO2 to compensate for the aerosols that you lose. I took that to BP leadership and I said, hey, this is not going to do what you think it's going to do. And they said, go away, don't bother me.
All right, so just to recap for people who are listening, it seems like there's two levers on warming that we're introducing. One being CO2, which is keeping the radiation in, and then, of course, the albedo aerosol, or the albedo influencing aerosols, which are reflecting away the light. So there's this balance going on, and the only one we hear about today is CO2. Which is interesting that there's another side to the story.
Yeah. So two minor addendums to what you just said. First, it's not just CO2. There are other human greenhouse gases, methane being the next most important. And the second is we do hear about it a bit when you hear about geoengineering proposals. Those are proposals to put deliberate aerosols up higher in the atmosphere than the tropospheric aerosols to enhance the albedo, increase the reflectivity, and so cool the planet. So it's a balance between the two. But it is a mystery about why the warming of the planet over the last 2 decades seems to be coming from increased sunlight absorption rather than the effect of the greenhouse gas, or the direct effect of the greenhouse gases.
At the beginning, you said that the albedo was the most significant effector of temperature. What can you compare that to the effect of greenhouse gases? Is there a
No,
way to?
both. No, they're both
Right.
significant. I'm sorry if I misstated or you
I see. So
misheard.
there's just two
Yeah,
levers, and there's a balance to
basically,
be
yeah.
struck.
And when I teach climate science, you start off with this kind of dumb model of energy balance, and there are just two parameters. There is the albedo, and there is the infrared absorptivity of the atmosphere.
Nice.
And it turns out that the surface temperature and hence the climate more generally is very sensitive on a physical scale. And the influences that we're talking about, 1% change in the albedo, a little bit of greenhouse gases, are physically very small effects. They're at the 1% level. But the climate is also very sensitive. The surface temperature of the Earth is about 300 Kelvin, 288, call it 300, right? The effects we're looking for are maybe a 3-degree rise due to human influences. That's a 1% effect. And so you might expect that the external influences that would create this 1% effect are about 1%. And it's true. So we need very precise measurements and very precise simulations to untangle what's going on.
And how precise do you think that our simulations are? Because I feel like one of the questions that always comes up whenever you start talking about climate change is people arguing about their set of numbers and what their set of numbers tells you about the current situation versus the historical situation. And so
Yeah.
how good do you think we are at actually making these models?
So it of course depends on what variables we're looking at. Let's just talk about the temperature now. Okay. And I would distinguish between accuracy and precision.
Mm.
Some sense of the precision can be had by taking the many different models that the UN uses and asking for each model, if I took today or pre-industrial 1750s, say, and doubled the CO2, so took it from 280 parts per million up to 560, and let it come to equilibrium, by how much would the surface temperature go up? And of the roughly 50 models that the UN uses, you can get an answer that ranges from 1.5 degrees up to 5.5 degrees. So the models have a great diversity of responses to increased CO2. We can go into the reasons why that's true, but just to say
These
a
are
fact,
generally called sensitivity, right?
yeah, there's the equilibrium climate sensitivity of the model, the technical name. How much would the temperature go up if you doubled CO2?
And is there what is the path to coming up with the correct sensitivity in terms of studying I assume it's studying the historic record.
Well, that
So
assumes that you
partly,
know what the correct sensitivity is too, right?
well,
It's,
we have some sense
well,
because
you'd compare those two levers to the actual temperature of the air, right, or of the
Or
planet.
like historically, you're saying?
Yeah.
another way of getting at, well, there are several ways. One is you can compare the model results, the history, driven by not doubling CO2, but whatever you think the history was of CO2 and methane and aerosols, and compare that with the historical record. And people do that. And the answer is there's a terrible dispersion of the models also.
Uh-oh.
And we can go into the reason.
Yeah,
But
let's do that.
another way of getting the sensitivity is to go back to 1880 and ask what was the surface temperature then? What was the human influence? Essentially zero, close to it. And then go to the present day and ask what's the human influence now and what's the temperature now? And by dividing the two, you can get some sense of how sensitive things are. there are lots of uncertainties in doing that exercise. People have tried. First of all, do you really know the temperatures? Way back then. The second is you probably know the greenhouse gases way back then. The second is there are natural fluctuations in the climate system that have nothing to do with external influences, but are there in the record. El Nino is the most familiar one, but there are others called the Pacific Decadal Oscillation and so on that last for much longer times. And you
Probably
have to
pegged to
take
the sun's activity to some extent too.
no, it's people have
Well,
speculated about
let
that.
me back that off a little bit.
Yeah,
Probably
yeah,
pegged to cosmic influences in general. Like
perhaps, perhaps, but they're regular, as far as we know, regular oscillations that last 60 years, 70 years. And you've got to take into account the presence of those in the temperature record if you're going to try to do an accurate measure of the sensitivity. So there's all kinds of fights and disagreements about what should and should not be done. So that one is unsettled, I would like to say. So I forgot where we were in this long train of we were talking about models, right?
We were
And
talking
I
about
got off
models
on
and we were
Earthshine.
talking about
Right.
sensitivity
Right.
and you were kind of going to lead us into the discussion of what affects the sensitivity of the models and how
All
they
right. Okay.
disperse relative to historical
Yeah.
measurements
So
and predictions.
okay, good. So
we also haven't reached the part in the story where people are trying to save the world. I'm curious when that happens.
all right, let me finish up on the sensitivity in the model discussion. The so the paradigm you should be thinking about is there is this climate system, and it's isolated from external influences. No variability of the sun, no variability of greenhouse gases. It's just doing its thing. And now in comes humans who are going to crank up the greenhouse gases. And what you're interested in is how is it going to respond? And how much did the temperature go up? Did storms change? Precipitation, winds, whatever. When you do that, there is the direct response, namely, you added CO2 to the atmosphere. That makes it a more effective insulating layer, and therefore it's going to raise the temperature. Fine. But when it raises the temperature, there are so-called feedback mechanisms. For example, on a warmer planet, there will be less snow and ice. That will decrease the albedo. It will make the planet more absorptive and further raise the temperature,
But
amplify the temperature raise.
what about
That's a
clouds on a
feedback.
warmer planet?
I'm sorry?
But on a
Yes.
warmer, so you have like the
that's
decrease in the reflection, and then I think when we were talking to Richard Lindzen, he was
Yep.
banging on about the iris effect.
Yes, the clouds influence the infrared as well as the shortwave. All right. So we've just now gone through two feedback mechanisms, right? The surface albedo, the clouds, the radiative effect of the clouds. There's one having to do with the temperature profile of the atmosphere changes when you change the temperature at the surface, and so on. So there are these feedbacks that net enhance the direct effect of CO2. You cannot build those feedbacks into the models by hand. They are emergent properties from the models, and they depend a lot on what parameters you put into the models. We haven't talked about subgrid parameterizations. We can.
And is this just because we don't have a very good understanding of the way that these systems work together and how they respond to one another?
Yes.
That's weird to me because we've been watching for so long. Is it just...
So the most recent IPCC report, which came out 2 years ago, a year and a half ago, had this embarrassing problem that the sensitivities of about a third of the models were much too high to be plausible.
Yeah, they were like went
Much too.
totally off the rails. They were predicting like up to 10 degrees of warming or something like
Yeah,
that.
I don't remember the numbers, but they were too high, much too high. And so what they did was to say, we're going to supplement the model results with observations of these processes, the ice albedo feedback, cloud radiative effect, lapse rate feedback, and so on, and come up with a more sensible number. And so it's kind of an embarrassment in many ways that the models, an admission that the models are not really very good at all. I'm going to raise my chair here just a little bit. Come back. Um, so that's a little bit about the difficulties with the models. We're just talking at the global level now, average surface temperature and so on. If you ask, what about the regional level, like state of California, that kind of size, or even North America, they're terrible. And the modelers will admit it quietly in research publications, a little bit less quietly in private emails, but you never hear about that in the mainstream discussions. But you can see it. You just have to open up the regional predictions in the IPCC to see how all over the place they are.
So there's a range of suggestions in the literature at the time, or in the reporting based on the model. I don't know if it's being published, but is there?
I guess
Are there?
I'm a little confused because I'm like, okay, so if you have historical data, like let's say you can't really go back to 1800 and really trust temperature readings. Let's say you have decent proxies for CO2, but you have an approximate historical readout. And let's say with the advent of the satellite era, you have decent readings of albedo. How is it that we can't put together a model on historical cycles that gives us a realistic result?
So people try to build these big GCMs, which are general circulation models. They cut the Earth into 10, 50 million voxels, and then use basic laws to follow mass, energy, 10 minutes at a time through the voxels. And sometimes you have clouds, sometimes you don't. The basic problem is that the voxels are pretty big, typically 100 kilometers on a side in the atmosphere. That's pretty big. There's a lot of action that goes on at much smaller scales. Dick would probably talk about tropical convection, right?
Yep.
The thunderheads that go up happen on much smaller scales than 100 kilometers. And so you can't follow them in detail. And what you have to do is make some kind of approximation for their presence and effect. For example, if in a given grid box, the temperature is X, the sunlight is Y, the humidity is Z, how many clouds do I expect? Where are they? What effect might they have on the radiation, both short wave and long wave? Those are called subgrid parameterizations. And not only for clouds, but for other things as well, you have to make approximations. Different people make different approximations. They try to ground them in physics and observations, but in the end, they're different. And so the models give very different answers because they're so sensitive.
And are there teams starting to show up? People who are leaning into the more alarming side of things, and people who are.
I think the modelers, the people actually doing the work, are pretty
Academic about it?
pretty neutral. Yeah, they're by and large pretty good scientists. I mean, there were some outstanding exceptions we can talk about perhaps anonymously, but by and large, it's pretty good science work. I wish the quality control were better. I wish the answers were better, but they're doing it with integrity.
I guess I'm still a little bit confused because if you have teams that are trying to look, let's say we have a model, we have all these parameters, and surely there are some models that must more accurately spit out an outcome for, let's say, cloud cover or something.
Yeah.
And is that not the case?
Well,
Is everybody just
remember,
wildly off with their models?
yeah, yes, that some of them are really wild. So, as an example, you can look at when the models are run in equilibrium and we were not hitting them with extra CO2. The range of average surface temperatures varies by 3 degrees. Then we both, or the high model and the low model, are alleged to both plausibly describe the equilibrium state of the climate. But the surface temperature average differs by 3 degrees. That's a lot,
Yeah.
because that's how much we're talking about for the whole global warming catastrophe, alleged catastrophe, all right? And certainly a planet that's 3 degrees cooler than another one has got a lot more snow and ice on it. So its albedo is going to be different. But somehow there are other things in the model that compensate, and there are just a lot of knobs that you can tune, all right? And still get something that looks about right.
Well, about right and actually right, right? So if we're
Well,
talking about a single one of these, 100-kilometer square voxels,
yep, yep.
is it just the fact that somebody's model will work for one voxel, but then it doesn't work for the neighboring one? Is there nobody who can accurately tune the knobs in such a way that it's accurate for all voxels?
Right. No, there's nobody who can do that. Okay. And it's
Interesting.
usually not voxel by voxel, but it's region by region, like
Okay.
the whole Midwest, for example. No, you cannot tune it so it gets everything right. Not, and what you're interested in, by the way, is not the equilibrium description, even if it looked like, if the average weather in the Midwest or in the Middle East looked about right. That's not what you're interested in. You're interested in the response. If I up the CO2, how did things change? Which
Sure,
is
but it's a
very
good
different.
starting point. But it's a good.
Well,
If you
that,
averaged all of them,
maybe,
perhaps, yeah.
Yeah.
if you average all of them, maybe. All
Yeah.
right. But, if you look at the modeler's discussion, either in the IPCC or in private, the regional predictions for change are, to put it politely, not to be trusted. And they say that. But there are people who go off and work on build infrastructure to adapt to whatever change the models predict, but the models are just not reliable at all at that level.
So how does a model that's not reliable on a regional level suddenly become reliable on a global level?
It's not.
Okay.
It's not.
All right.
Okay.
Just making sure.
Yeah. I wish we had. I mean, there are graphs that illustrate all of this, of course, but
Mhm.
I guess the
can't pull
shocking
them
thing
up
is
in real
this isn't particularly unique in science. You might have an instrument with a certain level of sensitivity, and different groups are publishing different reports. And by looking at the assemblage of all that literature, you can maybe. I can't think of a single scientific topic I've worked on that didn't have a wide range of reporting with regard to some, cutting edge projection of what's happening in some quantitative system. So the problem, there doesn't seem to be a problem with that, other than people should be working perhaps to keep tuning them. But is this where we're still at today? Do we still have sensitivity issues? I don't want to jump into the future too fast, but I'm trying to understand where
No,
we're at with the
we
state of
still have
things.
sensitivity issues. I would say. Again, they tried to patch it up with the observations, adding the observations to the models.
So is there tension at this moment, or is it just sort of like this is
I
where we're at?
think, yeah, that this is where we're at. People are staring at their shoes, uh, and some of us keep saying, "Hey, there are real problems here, and be careful about making major societal decisions
Mm.
on the basis of these models."
What year was this, do you think?
Well, which
When you started making
for
noises
me,
about
yeah,
the caution.
quality, yeah, 2014.
Oh wow, okay,
Yeah. So
pretty late.
yeah, I was asked by the American Physical Society to run a committee to recommend a restatement of the official statement about climate change.
Hmm.
They had put one out in 2007 with great controversy because it said human influence on climate change is incontrovertible. And
And did they
that's
mean
not,
They meant warming of the Earth.
yeah,
Okay.
the human caused anthropogenic warming of the Earth.
Because my understanding is that from the earliest moments, climate change was actually about cooling of the Earth, all the way back in the 1970s, and there was a flip at some point. I'm not sure when that
Yeah,
happened.
we saw. So if you look at the global temperature record, never mind any given individual region, there's a warming at a good clip from about 1910 to about 1940. A rate just about as rapidly as we have seen over the last decade or two. But then it hits 1940 and it goes down, the temperature. It actually cools.
And is that
Until
due to the widespread use of petroleum products in the post-war era and the
we
proliferation of
don't know why.
Interesting.
When you try to build a model, let me finish the history and
Yeah,
then
of
we can
course.
talk about the cooling. And then in about 1975, it starts to go up again at about the same rate that it was early in the 20th century. Now, that poses a number of questions, obvious questions. One, CO2 was going up monotonically during that whole century, but the temperature wasn't. So that, first of all, tells you that there are other influences on the temperature besides carbon dioxide. The second, the fact that it was warming as rapidly from 1910 to 1940 as it has been over the last couple decades gives you some pause again in saying, hey, it's CO2. Because there's a lot less CO2 at the beginning of the 20th century than there is today. And then the third question, of course, as you asked, is why did it go down? And we're not sure, right? If you read the IPCC and you read the literature, they say it could be some combination of natural variability, increased aerosols, either from burning fossil fuel products or from volcanoes, or that the data is wrong or the models are wrong. We don't know. Again, a bit of an embarrassment. And again, if I were showing you graphs, it would be a little more powerful that you could actually see the research papers and the graphs that show all this. I tried to put some of this in the book.
Mm-hmm.
It's kind of surprising if all you've heard is the mainstream media story. I mean, I teach climate science at NYU, and I teach it right out of the reports and the research literature, and the students' eyes get wide open when they go through the course.
And is this something that can be solved by increased computation? Because we talked at the beginning about how you got into this from a background of computational physics and helping the DOE work out how to run these massive simulations. And now as we're heading into an era of even bigger computational heft, is it that we're finally going to be able to get a fine grain enough picture of the Earth with the number of satellites up that instead of, 100 by 100 kilometer, we now have, a kilometer by kilometer pixels that can all be computed? Or is that just still a total hope?
Excellent question, right? Okay, really good. So let's imagine shrinking from 100 kilometer by 100 kilometer down to 10 kilometers by 10 kilometers. Let's start with that. Okay. So I've taken the side down by a factor of 10, which means that the number of grid squares are going to go up by a factor of 100 because it's 2 dimensions. And you would say then I need a computer 100 times more powerful to have the same kind of computation. But that's not right, because what you're doing is following, let's say, the air from one voxel to the next. If the voxels get smaller, the time steps have to get smaller so that you don't jump over voxels. And so you're going to have 100 times more voxels, and you have to take time steps that are as 1/10 as big. So the computational requirements actually gone up by a factor of 1,000. Right? So if you want to go from 100 kilometers to 10 kilometers, you need a computer that's 1,000 times more powerful. Now, you might say, okay, I'll just wait a decade or 2 decades, but Moore's law is starting to slow down, and you may not have that. The second um, way of trying to tackle that problem is not by making more voxels, but by doing better subgrid parameterizations. And one of the most promising areas now, I think, is to use AI, of course, or machine learning more generally, to try to say, if the conditions in this big voxel are X, Y, and Z, then here's where the clouds should be, and this is what they're doing. And there are projects, the ones I know best are ones at Columbia called LEAP, and one at Caltech that are trying to use AI. There's also a similar thing in oceanography and ocean modeling here at NYU to try to do that sort of thing. But that's the fundamental problem.
And so if you have this fundamental problem, then the issues that accumulate on top of it is that over the course of the last, I mean, I would say probably since the 1970s, I think that the population bomb and limits to growth really set this stage for where we are today. You know, the modern environmentalist movement is founded on a very Malthusian perspective that the population is going to grow, is going to destroy the planet.
It's a very zero-sum situation with us and the planet. It's like,
yeah. And
when did those flavors start appearing with respect to, well, incentivizing academia to pursue the more catastrophic end of this spectrum, and in terms of the public support for those sorts of modelings?
I think the turning point came in the 90s. Al Gore and the movie Jim Hansen popularizing catastrophic futures.
Mm-hmm.
The actual, I mean, might be worth, again, a little bit of fact. The actual welfare of humanity soared enormously from 1900 to the present time. Population went up by a factor of 5. Lifespan went from 32 years to 73 years average. GDP per capita in constant dollars went up by a factor of 7. Literacy rate went up by a factor of 4. Anything you can measure is much better today than it was 140 years ago in 1880 or 1900.
Mm-hmm.
During that time, the globe warmed by 1.3 degrees since 1900. To think that another 1.3 degrees as kind of the average projection for warming at the end of the century is going to crash humanity, it just beggars belief. We are a remarkably resilient, adaptive species. And in fact, the IPCC reports, if you read them, as opposed to the summaries that the politicians put together, they don't say anything at all about catastrophic changes like that. All of the scenarios have GDP going up, the world getting better, wealthier, and so on.
I think that what the fears reflect is a distrust of the massive technological system that we have built for us to inhabit. And I think that people are I think maybe consumerism is the thing that freaks people out the most, where, you get an appliance now, like a washing machine. The washing machine is not made to last 50 years. It's meant to last maybe 10.
Yeah.
And the same thing with cars. Like, people are like, don't buy a car that's newer than, maybe 10 years ago at this point, because the quality of the machines has just started to go down. And so I think that what people are worried about is that it seems like we are on this exponential trajectory of consumption. And so the only lever that they can think to use to break that is is fears of extinction, is fears of these massive catastrophes that are waiting for us.
So, if I may, without insulting you, it's not meant to be. That's a very first world perspective.
Absolutely.
All right. There are 6 billion people who wish they had a car, who wish they had a fridge.
But I think that feeds into it, right? Because the people in the first world are like, oh my God, what's going to happen when everybody lives the way that we do?
Yeah. Yes.
And we haven't solved that
I think
problem.
there's another element too, where these really loud first world voices are also crammed into cities, and they hate traffic jams, and it's a sort of brutal life living out the middle class world of office worker in terms of your everyday interactions and experiences. You don't really spend a lot of time in the woods. You don't get to see most of the planet unless you go on vacation or take a cruise or something. And so I feel like there's that skewing of the lens as well.
And I think that that's what's driven fears of overpopulation too, like from the 1970s. Like if you read Paul Ehrlich's work, he's really banging on the drum of like, we need to do something to stop these hordes of people in the developing world from being able to reproduce. And it's deeply frightening to read because you know that this is a voice that's getting a lot of traction in political circles, and then decisions are being made on the back of that. And so you have this really, really strong first world voice where there's a lot of agency behind it to be able to say, okay, this is what we're afraid of, and we're going to be able to pressure the rest of the globe in order to assuage our fears.
I don't think they are going to be. We are going to be. So first a quote, which is remarkably prescient. Anthony Downs was a social scientist working in Los Angeles in the 60s, 70s. And he was watching the smog get worse and worse as more people were getting automobiles. And he wrote a wonderful paper, which is worth reading, called Up and Down with Ecology in 1972. And one of the quotes he's got in that paper is that the elite's environmental deterioration is often the common man trying to improve his lot.
Mm.
Right? So that's exactly the kind of fear that you were just talking about. When you listen to the more advanced countries in the developing world, India, as an example, China is already out of the developing world, but India, basically they're saying, to hell with you. I've got much bigger problems than to worry about this vague climate thing that's going to happen 50 years from now, and you can't tell me exactly what's going to happen. I've got to provide energy for my people. And it's hard to disagree with that stance.
Yeah, but the thing that kind of freaks me out is that because we live in a global world, we know that there is the ability of the developed world to apply incredible economic pressure onto the countries that are still trying to develop these things.
Maybe. There is a moral dimension to the discussion. But also, if the US will not, for example, fund fossil fuel projects in Africa, the World Bank or IMF or whatever, well, that's fine. China's going to step in and fund them and earn the loyalty of the countries involved. So it's going to happen anyway.
But that's kind of bad news for the United States if that's what happens, right? Because I feel like our prosperity is dependent upon the complex assembly of allies that we currently have.
Yep.
And I think that it's hard to see the world as not being divided between the growing influence of China and the influence of the United States. People are really worried that the Pax Americana is starting to fall apart and that America's influence on just global trade is fading. And if this sort of mentality about we have to stop the developing world from using fossil fuels catches completely, then it seems like we're running a serious risk for future American stability.
That's right. That's right. That's why there are a number of us previously kind of ostracized, canceled, whatever, who are trying to remind people of some of the facts you just reeled off and some of the implications of the choices that are being advocated for. And we're starting to get some traction, I think.
Who do you get the traction with?
Sorry?
Who do you get traction with?
The audiences that will listen, CEOs, general public discussions. Even the New York Times finally admitted a week ago that wind and solar are unreliable sources of electricity, and you're going to need some backup. That's a start. All right. I could go into much more detail about that. But, techno-economic realities, I think, are starting to bite. You can look at the gas boiler ban in Germany. You can look at the fertilizer ban in Holland. Those are inducing political shifts there where people are saying, hell no, tell me again why we're doing all of this. And the answers are pretty weak, actually. I think we'll see the same sort of thing in the US as the internal combustion engine bans start to become closer in time.
Yeah, are you watching California's approach to this pretty closely?
Absolutely. Absolutely. Yeah. Both having lived in California for 30 years and now having a foot in California again at Hoover.
And so what are you seeing happen?
California is maybe a world unto its own.
It's absolutely true.
Apart from the climate road of prosperity, EVs are probably pretty well suited here, but the grid is starting to have problems because they're taking away too many what are called dispatchable generating resources. Too much wind, too much solar. Cost of electricity has gone up enormously here in the last many years. So Californians may be willing to tolerate it because they like to think that they're at the vanguard of the energy future. But you go out and around the country, most people are not willing to put up with all of this. If you're going to make changes, you have to do it slowly. And there is a great rush to try to show climate action on a few-year timescale. And that deteriorates one of the fundamental vital systems of society, namely the electrical system.
Seems like there's an obvious stick there with, your economic future is going to hurt more, but I still feel like on the other side, the moral argument of take care of the planet is somehow that's hard to contend with. I feel like for most people, it doesn't taking care of the economic future of your children for some reason doesn't have the same, I don't know, what is it, almost holy mission to it in today's mindset. And I don't know how that happened.
What about taking care of the current and future generations of 6 billion people?
Yeah.
Who have only 10% of the wealth and well-being that you have.
Yeah. Why is there a sense of? Do you have a sense for why that doesn't weigh on the scales in the average person's mind on the street as the concept of taking care of the planet? Is just because the planet is so big, it's almost this. It's almost Gaian, or it has this bigger than.
There is that. I think there's also an issue with timescales. If you say you're saving the planet, that's a multi-decade timescale. You can hide or misportray progress. You can say we're getting there, but it's going to take forever. The politicians can blame all sorts of failures on the fact that this is for the long term. Whereas if you're trying to improve the standard of living in Rwanda or something like that, that's a pretty clear, immediate task, and either you can do it or you don't do it, right? So I think the long time scale plays to the political leveraging.
I just feel like it doesn't. The idea of taking care of future generations doesn't have a good slogan for it right now. It's there isn't that cultural.
Well, I think that people are trying to take care of future generations. They're just trying to take care of them regionally, right? So you have I think California is a great example of this, right? Because California has motivated itself into, I think that they have a plan to ban internal combustion engines by 2035.
20, yeah, I can't remember if it's 2030 or 2035, but yes.
Okay, so like they have the plan on the books, and the rationale for it is understandable because you go to Los Angeles, and as you're driving into that basin, it gets really grimy, and it's just kind of unpleasant. Like you can
Right,
tell that it's
right,
it's a polluted place, and
right.
Californians tend to be really gung ho about maintaining natural spaces and taking care of the environment, and so I feel like the slogan of taking care of the earth and taking care of the
Yeah,
environment has very much caught in California. But because it's such a wealthy place, that it's completely non-transferable to a place like, I don't know, I think Iowa comes to mind because Iowa's the corn and pig basket of the country. And you have completely different incentives that are at work in a place like Iowa versus a
right.
place like California because you don't have a big tech sector. You don't have a bunch of coastal elites that are like, well, I want my woods to be super pristine. You have people that are just working to produce goods, and the production of goods is deeply influenced by all of these economic
Right.
decisions.
And you have larger distances to cover and greater climatic extremes to deal with, or weather extremes, than you get in California. Right.
Can you say more about that?
So the performance of EVs depends very much on the ambient temperature.
Mm.
If it's hot, you're going to run the air conditioner, the battery doesn't work as well, and so the range goes down. And if it's very cold, you're going to run the heater, the battery doesn't work as well, and the range goes down again. And so if I were living in rural Iowa, I'd be pretty reluctant to buy an EV. Whereas coastal California, it works just fine.
And it seems like there's an inescapable aspect of personal automobile use. Like, in an ideal world, we would be able to have sufficiently good mass transportation that wouldn't be a thing. And so I wonder why there isn't more of an effort to build these sorts of infrastructures that would relieve the pressures in a different way.
There are efforts to do that. New York City, for example, just passed a congestion charge on vehicles entering lower Manhattan, and that money will be used to improve the subways and buses. But so I grew up riding the Manhattan subways and still do uh, occasionally. It's the best way to get around.
Yeah.
We spent a lot of
Um,
time on them too.
yeah, right. But they're not as safe as they used to be these
Hmm.
days, and that's a downside. Um,
In,
so,
in what way? You mean?
just incidents of either crime
Mm,
or mentally disturbed people. Um, so, as you may have heard, the governor deployed the National Guard to the subways a couple of weeks ago.
I didn't hear about that.
Yeah, so there's increased presence there. I still ride them. Okay, fine, but public transport is probably it's the best of several bad alternatives.
Because, I
Well, it's
mean,
like the thing in California. It seems like people don't want to move. Like you're gonna have to put these rail lines through people's neighborhoods and
Yeah.
through, especially through some of these really fancy neighborhoods along the coast and so forth. That seems to have been the main impediment to implementing. It's kind of insane that like we live in Southern Oregon, and it's kind of crazy that there isn't just a train that goes down to the Bay Area. You have to go, I think, 2 or 3 hours east to catch the Amtrak,
Yeah.
and it makes no sense because it's going to Portland anyways. But of course,
California
yeah.
tried to put in a high-speed rail system through the Central Valley. You have in California, I think, and maybe Oregon too, the kind of last mile problem. So you get deposited in the center of the city. How do you now get to some distance to wherever you're going? It's not so easy.
And I feel like that's one of the biggest problems is that, so I recently finished reading The Power Broker, which is about Robert Moses and
Oh yeah,
the,
yeah,
the institution of car culture. And I had no
right,
idea how influential he was in the development of the highway systems in America. And Robert Caro does a really good job of pointing out that the decisions that were made in the 30s onwards are decisions that are going to take hundreds of years to undo because the cities at the time were really small still, relatively
right,
speaking. Long Island, when Robert Moses started working on his Long Island highway system, was basically farms, completely
homelands,
all the way
right,
through. And he was really insistent about not including right of ways for public transit as he was building these highways. And so now you have this infrastructure that doesn't have any excess room on either side of it. And so you
right.
can't add a train to it. And the highways are laid out in sort of weird ways that they aren't very convenient for people to even get to in order to take the trains if they were associated with the highways. And so now you have all of these cities that are built up. And what Moses was able to do, in the 60s and 70s, because he had so much power, is he would just raise entire city blocks in order to build these
Right.
expressways. And I feel like the public, I just feel like you can't do that now to build trains, probably rightly so, because it was a complete catastrophe for the communities that he did that to. And so it just feels like an intractable problem. Like everybody realizes that we're at a point where we really need to change the material basis of civilization. We need to change the culture, but nobody knows how to. And so climate gets folded into it as this pressurizing force. And so
This
there's
excuse. Yeah,
exactly, but it seems like there's not really a clear way forward. It's alarmism without a positive place to grow. And I wonder, in all of your time in politics and in research, if you've seen plausible paths forward that are actually actionable as opposed to things that are pipe dreams.
that's really hard. And it depends which problem you're trying to solve. You're trying to solve quality of life and local pollution issues. You're trying to solve CO2. They're different problems and would have different solutions. I think you can look to the new built Asian cities for how urban life might be uh, made more environmentally friendly. I spend some time in Singapore every year, and I don't want a car in Singapore, and most of the Singaporeans don't want a car either. And they have ways of incentivizing um, the absence of automobiles. It's very expensive to have an automobile there. The taxes, the mass transit system is actually really excellent. The metro, and the city's dense enough to be walkable when the weather allows. It's pretty hot, so you walk underground a lot.
Hmm.
So you look at designs like that, the way they've grown up, and that's one way of doing it. But there are existing Asian cities, and think of Hanoi or Beijing, where you don't quite have that opportunity to do a new build. How do you fix New York or LA? I'm not sure. LA put in light rail during the time I was there, and I think I don't think it changed the traffic at all. But what it did do was to create dense corridors along the rail where people built apartments and moved in so that they could take the train. But it wasn't a big enough effect to really affect the overall LA traffic problem, which just got worse over the time that I've known Los Angeles.
Mm-hmm. And
No,
so,
I no,
oh, go ahead.
no, go ahead.
I wonder about the the two Americas, because if we compare New York, San Francisco, Los Angeles, maybe Miami, Seattle, like all of
Mhm.
these really, really dense areas to places, again, like rural Kansas, rural Nebraska, it feels absurd to have a single federal policy that dictates the way that these things are going to run. And so, do you imagine that this is going to become a much more piecemeal field of regulations where California is just going to keep trying to do things that make sense for its large cities, and states that don't have this huge population center are going to have completely different regulations that
Well,
prevents the country from moving together?
so we have that kind of thing already in other domains, right? Whether it's regulation of alcohol or marijuana or regulation of reproductive rights, they have devolved state by state. Unfortunately, because automobiles have to be manufactured, California carries much more heft than the other states just because that's where a lot of cars get bought, right? 10-15% of the country is in California, and they buy that many more automobiles. So they influence the standards. I think on the automobiles, we have gone, just to zero in on that one for a second, we've gone too far, too fast in the sense of everybody's thinking pure battery cars. And a much better solution would be a plug-in hybrid, which has enough battery to get 50-mile range before internal combustion engine kicks in. And you can then have a range in the car of 400 miles if you're going to drive that far. But most people drive 40 miles a day at most, and so you never really run the gasoline engine in daily life. The cost of that kind of vehicle is actually less than a battery vehicle. Toyota bet on that, was not very happy with pure battery vehicles, and I think is doing very well for that reason. So I think an unreasonable, technically ill-informed rush for the better prevented the government from going to the good enough.
Interesting.
You see that a lot.
I heard recently that the actual, if you include little tire particles, that the electric vehicles, since they're heavier, actually contribute worse emissions. Is that true?
I've heard the same. It sounds plausible to me.
Yeah.
I have not looked into the numbers, but it does sound plausible.
I mean, regarding this division thing, I think that there's a really dangerous social element to this. So we live in a pretty rural part of the state, but what's interesting is that most of the voting population for our state is in a city, but there's plenty of people outside of the city who are feeling increasingly threatened by all of these narratives, because of course they look around, it's a beautiful green world to them, and yet it seems like there's a threat that their way of life will become increasingly less tolerated. And it even goes so far as to, and I think this is a valid concern for them, because we had a friend who built an art exhibit around the idea of, what if we took the entire world's population and put it in one city? Well, it would only occupy, a small piece of land the size of, a large state in America.
Yeah.
And then the whole rest of the world would be a beautiful, pristine ecosystem. And how wonderful would that be? And and Anastasia and I were just kind of like, oh my God, no, I won't live there. I mean, I'll be a park ranger or something.
Yeah, right. Nobody will ever get to see it, right? Maybe the ranger.
And so it's a valid fear, and I feel like that derives. What's sad about that is that these people who feel threatened by this narrative end up jumping on other political programs that might not be so good for their long-term interests as a result of it. That's the really tragic angle, I guess.
I think there is a political zeitgeist of fear that ways of life will be destroyed. Things have gotten out of control. I think you started off with that sort of theme, and it's understandable. All right, it is certainly understandable, and the environmental fear, greenhouse gases, global warming is maybe a manifestation of that as well. The problem is that to fix that alleged problem, you need a complete redo of the world's energy system, which again is one of society's lifebloods. And it's like saying we're going to completely redo your neural system or something like that in a human. And it's just It's going to be very difficult, take a very long time, be very expensive and disruptive. And it's probably not the most important thing, frankly.
It's not the most important thing because our models are so uncertain and it seems like our conclusions are perhaps spurious. And so
And
there's,
the world, I'd like to say, it's like when we talk to most of the people in the world, 6 billion, it's like telling people, you better worry about your cholesterol while they're having a heart attack. All right. You've got real, immediate, soluble problems. And you got to deal with those first.
I still can't for the life of me figure out how in the world the concept of environment became separate from the economic environment or the well-being of people. I don't understand that fracture and how it happened or how it plays out inside of people in general.
If you are a rich, relatively young person, maybe not even rich, but just living in U.S. society, you have no idea how lucky you are, and no sense of what it takes to support that way of living. I mean, shouldn't blame the young people. I mean, I think plenty of adults
Well, no, I
have
think they
that
feel
same
that.
problem.
I think people feel that. They feel that naivete and they don't know what to do about it. I think that's why they latch on to these bigger moral campaigns because it feels bad. They realize that they're in this really privileged position and they feel some mixture of guilt and uh, just disempowerment about driving the machine that they're riding on.
Mm, maybe many of the people I've talked to, not scientists and engineers, just don't have that sense at all.
interesting.
I think the cure for that is education, right, says the professor. Right? Um,
What kind of
um,
education?
well, understand a little bit about the demographics, income of the world. Understand a little bit about energy needs. Understand where energy comes from. The fact that it's really about systems, not particular technologies. Understand what the growth in energy needs to be in order to let most of the planet develop. Things of that sort.
So a liberal arts education, basically. You need this global systems analysis to be a part of everybody's academic curriculum. I feel like that's
Yeah,
gotta come from the earliest years almost to look at
yeah,
things in this new paradigm where the countries are not these discrete units that we can
right.
read about different kings and stuff. We need to think about history in these systematics uh,
I'd even start
modeling.
at the younger grades, just at the town and country level, right? I mean, the fact that you can live in Oregon or I can live in upstate New York. What does it take to make that happen with the current standard of living that we have? Food has to be grown and moved from somewhere else. Somebody's got to run generators and transmission lines. There needs to be fuel refined, transported to the filling stations, et cetera, et cetera. Um, Changing all of that might be desirable, but it's not going to happen overnight unless there's some catastrophe. A lot of what we were talking about in the last 30 minutes or so is really a values discussion,
Hmm.
not really, the usual thing I deal with are facts, theories, models, uh, more objective. And my opinion about values and subjective issues is no better than anybody else's. And in fact, my wife would say it's worse. Uh, and
I mean, I don't
so,
think we're trying to pick sides on the values issue so much as
yeah,
understand why
all
there
right.
seems to be apparent contradiction in the values assignment, right? I think people really do all want to take care of the world, and it's strange how people see that as following one set of actions when in fact it might work against them. I think that's the more interesting story there, not necessarily which way is the best way to take care of the world. It's just that, do you realize that you're sort of undermining your experience too? That seems more the issue.
Mhm.
It, in part, but I also think that it's impossible to ignore that the question of climate science is dead center at the values that we have politically. That's kind of where I was hoping that we could go to next, because you worked inside of the political system. You worked for the Obama administration. You've also worked for BP. You've also been an academic. And so I feel like you've crossed all three of these spheres and seen how they work inside and seen the incentive structures. And you must be intimately acquainted with the way that climate science is the major motivating cause for people in our country, whether you align with
Or
it.
is the major tool that those who want to motivate employ.
Exactly. And so I guess I wanted to start with just some personal sense, because you say that, okay, before the break you finished with saying that restructuring all of these energy systems needs to be done slowly, because if it's not done slowly, it's going to break a lot of things along the way. And I imagine that you came to this realization pretty early. You wrote this book, Unsettled, which I think part of the reason that we're not going through the quantitative discussion is that you do an excellent job of it in the book. And it seems...
Get the book, everybody.
Yeah, exactly. And so we always try in the podcast to go somewhere that is beyond the source material. And so since the quantitative discussion is available, and you make this very strong case at the end of the book where you're like, look, there's a couple of things that we can do, but we most importantly have to remember that humans are an adaptive species. We've been through worse. You use this example of living in earthquake country. You're like, oh, there's earthquakes. We know there's earthquakes. We deal with it by bolting the house to the foundation and screwing the bookshelves to the walls and still continuing to live in California, even though we know that this thing is happening. And so from the inside of the political system, working for the Obama administration, when you started to present these ideas where you're starting to caution people that, hey, maybe our models aren't as good as we say, and maybe making all of these really catastrophic changes to our energy sector is going to be a bad idea, how do people react to that? Do you get a lot of traction? Do you get a lot of pushback? Is it that they're one way in private and a different way when they're standing up in front of the cameras? What happens?
So I think again it depends on which players you're talking to. I'm not going to name names of people that I've talked with. I think that's probably largely unfair. In the political system, there are different motives. I mean, the most important motive is to get reelected. A second motive is to try to do good when you're in office, in power. Climate science has been used as a club in order to, I think I have in the book this great quote from H.L. Mencken, who says the purpose of practical politics is to keep the populace alarmed by a series of mostly imaginary hobgoblins, so that they'll be clamoring to be led to safety. And, pick your favorite hobgoblin. There was the missile gap in the 60s. There was Y2K. There was COVID, which was a real. Some of them are real, of course. And then there's climate, and soon there'll be AI.
Well, even climate change is real, right? It's just a matter of what you make of it, I suppose.
Well,
and the same could be said about COVID, I suppose.
When people say climate change is real, I think that confuses several things, right? When you say climate change is real, well, of course the climate changes. We have ample record of climate changes well before humans had any influence at all. And so when people say climate change is real, what they really mean is that humans are causing the climate to change. And there's no doubt that humans are contributing to the changing climate.
This might be a good opportunity for all of us to say we believe in climate change, just so that YouTube doesn't
Actually,
downgrade
I
this video.
believe in the changing climate.
Oh, there we go.
Okay.
All right, I do too.
All right.
I actually think that it would be.
Come on, say you believe in it
I
too.
really think that it would be politically useful for both sides to
start there?
converge on the point of I agree with climate change or I believe in climate change or whatever it is that you want to say, because I'm like, look, if you can at least agree on the base reality that the climate is changing, then you can start to have a discussion of, okay, what are the motivating factors? What should we do? And at least you're in the same room talking about the same thing, as opposed to just completely talking in different directions, which I think is what happens a lot.
You know, when people say we're going to fight climate change, that's sort of ridiculous.
I
Right?
always
Go ahead.
think of a civilization that has like lined up the virgins and is going to throw them into the volcano. And so it's like
Right.
when they're like, we're going to fight climate change, I'm like, which virgins and which volcano are we going with this time? Because it's such a human thing to see a crisis and to say, we're going to solve this crisis. And if you have the wrong infrastructure in your mind for thinking about the crisis and thinking about what it is that you're going to do to solve it, you're not going to be doing anything useful. And that might be worse than just not doing anything at all.
So this is a great place to remind you or tell you about another Anthony Downs gem in that 1972 paper. The main subject was what he calls the issue attention cycle.
Mm-hmm.
And it's got 5 phases. Phase 1, some serious problem bubbles along among the experts, well below public radar. So think early IPCC reports. Phase 2, the problem bursts into public consciousness with great enthusiasm for solving it. Phase 3, everybody realizes this is not going to be so easy. I can go on, I'll tell you about phase 4 and 5 in a minute, but I would submit we are firmly in phase 3 with respect to the energy transition. Phase 4, the problem declines in prominence and is perhaps supplanted by some other problem. Think AI. Phase 5, the regulations, the organizations that have been put into place endure, occasionally pop up in public perception, etc. And it's spooky how well that fits what's going on with the energy transition now, even though it was written 50 years ago.
And did you see that when you were in the Obama administration?
No, I think, no, we were in the early phases. There was enthusiasm. We're going to solve this thing. But anybody who had studied so I'll tell you another relevant story. I'm in BP starting in 2004. And I start to learn about the real energy system. I mean, physicists know about energy, but all we know is it's conserved. It's not. You don't know about the real energy system.
By the
And
way, what was your role there? Why was BP interested in your expertise?
I was chief scientist at BP. That was my title. And when they hired me, I protested. I don't know anything about energy. And they said, we don't want you to help us find oil or gas. We know how to do that. What we're interested in is figuring out what beyond petroleum really means in a practical sense. What technologies, what businesses should we be thinking about as we think about alternative and renewable sources of energy? And that's why I was there. And it was a great education. I learned, energy from a global energy company near the top. I never had to make any money. They just wanted advice, strategy. Now I've forgotten where I was.
You were telling a story
Oh,
about
yeah.
BP.
So I'm starting to learn about energy demand, energy uses, the energy system. I learned a lot, by the way, from a set of books written by Václav Smil, who writes wonderful books about energy. And at some point, I wrote a memo that basically said, this net zero thing is not going to happen because of the trends and the recalcitrance of energy systems and so on. And I sent it up to the BP leadership, and sort of got a smile and said, "We know," but they never let me publish the memo. It was only 10 years later when I published the essence of the memo in an op-ed in the New York Times on the eve of the Paris conference. Basically said, mitigation is not going to be particularly successful, and the dominant mode of response is going to be adaptation. And you should have seen the comments that came back from the New York Times readers when I said that. Now we're 8 years later, and I think I've been proven right.
And so,
What were the
was-
comments? Sorry,
Sorry?
what were the comments? What kind of comments were you getting?
Oh,
actually?
this guy is shill for the oil company. He's going to destroy the world. Don't you care about the future of the planet? Things of that sort.
And so,
You're giving up before we're trying. Sorry.
what was happening inside the Obama administration? Because you would have probably been either, if not alone, then a minority dissenting voice to a fairly liberal administration.
I was, I was in the administration to try to help things go well. And my job was not so much to criticize the climate science, but to find the investments in energy innovation that would help move things along. And I did that. I wrote what's called the Quadrennial Technology Review, the first, that said these are the technologies that the government should be investing R&D in, and here's why we like these and not others. And many people have said it was a unusually well-written, well-thought-out plan. You can still find it on the.
So would you say this is a case where BP and the government had a shared interest in this same topic?
Yeah, BP had, I mean, it's funny to say, I was doing for the government the same kind of thing I did for BP.
Yeah, that's what it
Namely,
sounds like. Yeah.
An analysis of possible energy futures, of what energy technologies would be important, and what research programs should be started up to try to realize those energy technologies.
Did you give them
I
different
was
advice?
not at that time, I was not at that time very critical of the climate science story because I had not really dug into it very deep.
I see. So did you give them similar advice?
The national was different than the company. I mean, the company had to see its way clear to making money on some time scale. It had particular set of skills that and some skills it didn't have. Whereas at the national level, you can imagine marshaling a much broader array of resources to try to make it happen.
And so
you can also, at the national level, invest in a much earlier stage of technology than you can in a company that's trying to make money.
And so what did you advise the government to do?
Well, we
or
liked
BP for that matter.
Yeah. So one of the things I got BP started on was advanced biofuels. Not corn ethanol, which has no particular benefit except for the farmers, but ways of turning the cellulose in plants into motor fuel. And the rationale for that was the advances in biology that were then and still are taking place that might let you do that in an economic way. It still hasn't happened yet, but I think it could. And if you want fuel for ships, for airplanes, for heavy vehicles, that's an interesting way to be going.
Seems like there might be some scary externalities associated with this industrial agriculture, at least out where we live. It seems like there's some just my own anecdotal experience being out in the woods, and I feel like there might be some other effects on our future well-being if we're trying to farm our fuel as well.
Yeah, yeah. So, the improvement, the idea was you wouldn't have to use corn, but you could use virtually any material. The favorite material was switchgrass at the time, which is a fast-growing bamboo. But uh, on the issue of scale, energy is about scale. And I have a friend who was an agricultural economist who told me once, the only people who don't pollute are dead people. And that's not obvious either. So, the world, most people do not realize the scale of the energy enterprise. And you're going to have to do it at scale somewhere, whether it's enormous wind farms or enormous fields of solar panels, or enormous coal mining and coal trains. Uh, you have an impact on the environment. So choose your poison. Right?
Yeah, absolutely. Did you have something to ask?
I was just thinking, yeah, even nuclear, you still have some waste there to deal with that you can't get
Yeah.
around.
Although small, I mean, the nuclear waste is physically quite small compared to everything else that we're talking about. Just because nuclear energies are so much bigger.
And so much of these can be addressed through adaptation. Even I wonder, even with nuclear, if we can find a way to adapt to the nuclear waste in a safe way, with advances in nuclear technology.
A little bit. I mean, I'm a nuclear physicist by training, so I like to say the atom is my friend. Though I would not trust myself to design a reactor. When the waste comes out, there are really two. I shouldn't really call it waste; it's spent fuel, because only about 5 to 7% of the fissile material, the 235, is actually burned up. So there's plenty of energy left in the spent fuel, which could be recovered.
They use some of it, right, for like artillery shells and God knows
that's
what else.
That's the depleted uranium, which is even before you made the uranium into a fuel.
I see.
You had to enrich it, and you took the tailings and made penetrators or whatever. But the fuel really has two components. One is the products of the fission. So kind of middle of the periodic table, krypton, things like that, barium. And if you consider just those, after 1,000 years, they are no more radioactive than the rocks from which you took the uranium originally. It's not 10 years, 1,000 years. The other part is the actinides, the heavy nuclei that get made in the reactor. And those live for a very long time. So if you separate out the actinides and put them somewhere deep where they're well isolated, there isn't much of it. It's only a few percent of the mass of the spent fuel.
How difficult is it to separate out the elements?
Not hard. It requires, hot chemistry, but it can be done. People are doing it commercially. Then you have, a several 100-year problem rather than a 100,000 year problem.
This is probably a stupid question, but why can't we inject spent nuclear fuel into underground magma chambers, where it would just be or like into subduction zones where it just gets pulled into the earth and then.
So I have a friend who's a professor at Berkeley who's pushing the idea of putting the spent fuel into used boreholes. So you take a borehole which has been drilled into the rock, maybe to get oil out or gas out, or even specifically for this purpose. And you put it in a special canister, you put it down there. It's well isolated. It can be retrieved if you want to retrieve it. So it's a pretty good idea. There are regulatory issues, as always. You want to be assured of the safety, longevity, and so on. But
It seems like
it's not
the
crazy.
main impediment is people fearing those nuclear plants nearby them.
Yeah, that's not so much the spent fuel, but that's the nuclear plant
Right,
itself.
exactly.
And you can look, there are graphs, I teach this in my energy course. You can look at, number of deaths per kilowatt hour produced. And even with Fukushima, 3 Mile Island, and so on, the nuclear deaths are a couple orders of magnitude smaller than anything else.
And so did you advocate for developing nuclear when you were
Yes,
advising the Obama
when I was in the
administration?
department, I helped. I wasn't the only one, of course. I helped get a research program in small modular reactors started.
And these
So these
would be like
are
thorium or saltwater reactors?
no, still
They're
uranium.
just small.
Yeah. So here's the story about that, if you don't know. So a big reactor, as we have roughly 100 of them in this country and 400 worldwide, is it produces about a gigawatt of power. The total energy is 3 times that, but a gigawatt of power. That's as much as a pretty large coal plant. And in this country, we build them bespoke, as the Brits would say. Every one is slightly different. Some of them are very different. They all have to be licensed. And they all cost a lot of money. 10, $15 billion to build. Very little to operate. The operating costs are small. So you put down a big chunk of money. It takes forever to get it built and licensed. And then it starts generating cash. And you pay off the financing as it starts producing electricity. Maybe it takes you 20, 30 years to pay it off. The small modular reactors are a different model. They are about 1/10 the size, so 100 megawatts instead of 10 gigawatts. The theory is they will be built in a factory, not on site. So they will be built in a standard design. So think, Ford's assembly line, just chunking out the same item. You can move them to the site by railroad flatbed truck. They're that small. And you install one in a site, it starts producing, and then you use the cash flow from it to finance the next one. And so you build 5, 6, 8 in a site. The fuel is the same. It actually needs to be a bit more enriched, but uranium. Safety, economics, security, a lot easier. The problem, and so that sounds all great, and there are a number of companies in the US who've been trying to make all that happen. Some of them have gotten through the licensing, but the problem is that the first one is going to be expensive because you've got to come down the learning curve, and the interest rates are kind of high at the moment, so they're on hold.
Oh, they're on
That
hold.
said,
They're on
the
hold
Chinese
completely?
are building these things like gangbusters.
I mean, is there some concern that with more affordable, more delocalized nuclear reactors, that there will be a drop in maintenance abilities and more mistakes just slip through the cracks?
Of course, you worry about that, or more opportunities for accident.
Whatever's happening at Boeing really makes me suspicious of our
Yeah.
ability to maintain infrastructure.
Exactly,
You
yeah.
know what I mean?
Yeah. So you You do your best in the design to make them intrinsically safe, and then you have very high standards for operators and maintenance. But sure, it is I won't say more dangerous, but the consequences of a single problem are greater. And in fact, as with the airplanes, if there's one accident, it affects everybody.
Right.
The whole fleet gets shut down. So
I,
that's one of the worries people have, is that China or some other country will have another nuclear accident and put the brakes on what could be a nuclear renaissance.
why don't they put nuclear reactors underground, like deep underground?
Well, these would be in a pit.
Okay.
They wouldn't be above ground structures.
Hmm.
They're small enough that you can do that. You can look up the designs on the web. I mean, yeah, people have thought about that. But I think many people who have studied energy systems believe that you'll never get to net zero or close to net zero in the electrical grid unless you can have nuclear power in some way.
Yeah, it just
You
seems like
know about?
it
Yeah,
seems
go
like
ahead.
again, like I can't stop thinking about the battery externalities. The idea that you still, you might have stopped mining coal in your own country, but you're mining something somewhere.
Yeah, yeah. I think batteries in the end are not viable. So do you know about the intermittency problems with wind and solar? And does the word Dunkelflaute mean anything to you?
Mm-mm.
So Dunkelflaute is a German word. You'll forgive me, I don't speak German, but it means a dark stillness. And if you have a system that relies on wind and solar only, it can be plagued by Dunkelflauten that last up to a couple weeks long. So you are becalmed and you're dark because of clouds, and you're not generating any electricity. So you need a very capable backup system that can fill in for 2 weeks. Your
Like,
choices are batteries, uh, gas with capture, carbon capture, or nuclear. And when you go through the economics, nuclear is certainly a viable candidate.
and do you see it kind of as a race against the clock to get this infrastructure up and running before somebody like China has a major accident that sets us back another 50 or 70 years?
Um, no, because I think um, people will realize you're just going to have that anyway. And it'll be like an aircraft accident used to be, where, okay, we had a problem, let's figure out what the cause was and let's go fix it.
Yeah.
I think there is a race in that if we deploy too much wind and solar in this country or in Europe, the grids will go unstable and unreliable. And so we've got to have backup in place in some way, which means we shouldn't, for example, destroy fossil fuel plants too rapidly. One of the problems with energy generally, and particularly in the grid, is that the technical voices, the people who actually build and run the grid, the transmission lines, the distribution, the generating facilities, don't have much of a voice at the regulatory table.
Mm.
You can look at the PUC, the Public Utility Commission in California. In Oregon, I expect it's actually probably worse. And so you get, you'll excuse me, politicians and lawyers making decisions about a complicated technical system without appropriate technical input.
I believe Richard Lindzen made the same comments about the International Climate Change Committee, that there were very few actual scientists in these panels.
I think it depends on what level you look. Um, Dick is closer to the people than I am, but I think many of the technical reports that the IPCC produces are not bad. What's bad is as they get summarized and condensed for non-experts, they get corrupted.
And it's really striking to me how the green movement has really been against nuclear power pretty much across the board. Is
Um,
is is that just
that's changing. That's
yeah.
changing. So Michael Schellenberger, Stuart Brand, I can probably name some others as well, have all come around to be supporters of nuclear power done well. Because again, they realize if you want to go to zero, there are very few options that don't involve nuclear.
And is this an across the board does this have support across the board politically speaking? Because I feel like one of the problems in the United States is that every 4 to 8 years we go through a transition of administration, everybody gets cleaned out, and it just kind of feels like we oscillate around this point where nothing really moves forward. Everybody acknowledges that it's broken, but there's just no ability to work through it. And I wonder what you're seeing on that level. Do you feel like there is movement in the right direction, or do you feel like everything's just kind of still stuck in this morass?
I think you find bipartisan support for development and deployment of nuclear if it can be made economic. Again, the thing that's stopping at least one of the SMR efforts right now is just it's gotten too expensive because the interest rates have gone up. Right? But that's true of wind and solar as well. You know, those technologies, nuclear, wind, and solar, involve a lot of money put down at the beginning and take very little money to actually operate. That's in contrast to, let's say, a gas turbine, where it's pretty cheap to build the turbine, but then you have to keep paying for the gas to run it.
Mm-hmm.
So they have different finance profiles. And the capital heavy technologies like nuclear, wind, and solar have suffered as the interest rates have gone up.
As a
The
nuclear,
biggest,
yeah, I was
sorry,
just
go
going to
ahead.
say, as a nuclear scientist, do you have a lot of hope for fusion? I'm curious what your
That's
read
a
on that
whole other
situation is.
subject. Okay, I do know something about that.
Are you hopeful? Can you say at least as much?
So a question I've answered in public, and I've subsequently asked many of my friends who know, what do you think? Is when will we see fusion putting electricity into the grid for the first time in some plausibly commercial way? And my answer was about 20 years, so early 40s. Other people have said at least that long. There are two major problems, actually three, to be solved. So a little bit about fusion science, just real fast. Okay, you've got to create this plasma of hydrogen nuclei. It's very hot, 100 million degrees, and you have to confine it and keep it hot. And what it does is act as an energy amplifier. And when you're keeping it hot by pumping in either radio waves or particle beams, and you hope to get more energy out in fusion than you put in to keep it hot.
And is that energy out in the form of heat?
Yeah, well, it comes out actually in the form a little bit of heat, but a lot of it in the form of neutrons, fast neutrons.
Hmm.
So those have to be slowed down, and they're kinetic energy.
So
captured.
they would heat up some other element. Then.
Something around it, right? Okay, and eventually you wind up boiling water and making steam and making electricity. So one is maintaining a plasma that produces gain. We'll come back to that in a second. The second is you need fuel. The most favored fuel involves an isotope of hydrogen called tritium. And that isotope is unstable and lasts only 12, it's got a half-life of 12 years. And that means you have to be making the tritium as this thing is running. And the way you do that is to capture the neutrons, which we discussed, in a hunk of lithium. And when the neutrons hit lithium, they make tritium.
Hmm.
And then you have to separate the tritium from the lithium. And hopefully you make more than you consume in the plasma. So the second issue is making tritium. 1 gigawatt fusion plant will consume several times of the world's total supply of tritium in 1 year. So we're going to have to make a lot of tritium. So you have to be able to do that. And then the third is the wall that is confining this plasma is subject to intense radiation, not only the neutrons, but X-rays and electrons from the plasma nuclei. And you have to find some material that's going to stand up to that intense bombardment and not degrade, crumble for a year, 2 years. Otherwise, you have to keep replacing it. So there are kind of 3 major problems. We're furthest along on the gain. You may have heard, there was a big news story a few months ago that it got more energy out than in a kind of fusion involving a laser, inertial fusion. I was very proud to have written a report now almost 30 years ago that said, go ahead and build that laser. We think it's going to work, but we're not sure. And now 30 years later, I'm pretty happy to see it actually achieve ignition. It's still a very long way from making energy, but we'll be able to do a lot of great science with it, and it's a step toward energy.
Yeah, I felt like that headline maybe was a little misleading just because it seemed like powering the actual laser itself wasn't included in the energy balance.
So it was never, if you read the National Academy report that I chaired, the notion of energy production is never mentioned.
Mm,
This was a scientific facility meant to demonstrate proof of principle
right.
and then allow some follow-on experiments that would have exploited the ability to produce fusion.
Have you
It
have you
was
read
never
about
built as
I'm sorry, go ahead.
I was going to say, it was just never built as an energy facility. But the scientists don't get to write the headlines, all right? So
That's true.
Fair enough. Have you read anything about lattice confined fusion?
you mean low energy fusion?
It is a
Cold
low.
fusion?
It
What
is a
used to
form,
be?
not cold fusion. I
Well,
think it
cold
is.
fusion has a PR problem.
Yeah,
Yeah, right.
NASA's done a pretty cool study. I think there's just one study on this, which is impregnating some sort of metal with, I believe it's deuterium, and using the lattice by actually applying some electromagnetic pulse to it. I don't know if it's a piezoelectric compression, but some sort of compression occurs that leads to a much more ambient reaction. And I wonder if it couldn't sidestep some of the problems of tritium. I've tried really hard to reach out to these people, but we just keep getting shuffled around NASA. And part of it makes me hopeful that it's so promising that they don't want to talk about it. But I don't know if anyone's still working on it or not.
So as you may know, I was involved in the analysis, I'll say debunking, of the original cold fusion claims,
Mm.
1989. No evidence for nuclear reactions then. That was 30 some odd years ago. I'm still waiting.
Mm-hmm.
I don't know about these particular NASA experiments, but I do know that there are powerful general physical arguments that say this is not going to happen.
Yeah, I wouldn't throw it in the bin with that. It's worth checking out. It's called lattice confined fusion, and I think
I'll
it
have
is
a look.
promising energetically on the same order, but it seems like it sidesteps the containment issue, and
Yeah.
I think it's just a really interesting curiosity. I think they're still working on it, but yeah.
We can send you the
DD
paper.
will happen faster than DT. In fact, that was the paper we wrote in 1989 that said you should not be looking for, you should be looking for DD because the masses are lighter and the tunneling is better.
Mm-hmm. Mm-hmm. Well, I mean,
Okay.
if you see it happening in 20 years a little bit, it seems like it's only a matter of time before it's happening a lot a bit, and then you're really talking about nuclear as a holdover in the meantime. So it seems like that should dispel people's fears, who are thinking, oh, what happens 1,000 years from now when all of our mountains are packed with nuclear waste? It's like, well, it's not a plan in the long, long run, it seems like.
it's really hard to predict what the long run is going to look like. I mean,
And yet people fear that in some sense the most. I feel like they go to these enormous extremes of the accumulation of, if things continue exactly as they are forever, we'll be, up a creek.
Mr. Malthus.
Mhm.
But they don't. I mean, imagine yourself sitting in, 1000 AD, 1,000 years ago, fretting about what the world would look like if it continued on a linear trajectory.
I'm sure
Of
people
course,
did that.
Malthus was probably the most recent. Humans are just so wonderfully adaptable. I mean, it is the defining human characteristic. We figure it out, and I have a lot of faith in that.
Yeah, we're a really strange animal that can look at how we are and decide we want to be different in the future, even on on a personal level. But I
Yeah,
think as a species, we can really retool what we are, which is just so bizarre. I can't find any other
right.
animals that do that.
Yeah. Language is an important part of being able to do that. Writing is an important part of being able to accumulate knowledge rather than simply have it die with the individual.
And
So
to act upon it as well.
yeah, and then rationally analyze alternatives and make a pretty good choice. So young people many are so depressed about the future of the world, at least in the West, not so much in China, I think, or India.
Hmm.
And there's no reason that they should be so depressed. We should tell them all the great things that have happened.
Yeah. I wonder if you have a sense of what is most promising. What gives you the most hope? You look forward and, political infighting and high interest rates and all these things seem like they might be slowing things down. But what do you see that is really a light on the horizon?
I think modern biology is going to continue to be spectacularly fertile as we figure out how life works down at the molecular level and then cellular level and so on. The tools that we have for acquiring, analyzing data, and then doing experiments on organisms, just showing spectacular progress. You see some of it in medicine, of course. I mean, the ability to produce the COVID vaccines really rested on 30 years of basic science that we could do it that quickly, and it's only going to get better. So I see a lot of optimism for that. I see a lot of optimism also on the neuro side. I mean, the brain is one of the still remaining great mysteries, and figuring out how that works will have certainly medical benefits, but also, I think, technological benefits spilling over into the informatics domain, which I also have a lot of optimism for. People are freaked out about AI. I think we will learn how to use it effectively, as we have done for many other technologies. So again, it's adaptation, but not adaptation to natural circumstances, but adaptation to new technologies.
Mm-hmm.
So, very good reason to be optimistic.
And what do you spend most of your time working on these days?
Um, my passion for the last 3, 4 years since writing the book has been trying to inform a rational discussion of climate and energy. And so I'm out and about a lot, talking to audiences. But then on the research side, I'm most interested in the universality of energy use in the developing world. What does that mean? Right. So if you take most of the countries in the poorer half of the planet, and so that's per capita income less than about $10,000 a year, $30 a day. And you look at how their energy use grows as they become richer. They're still not very rich, but richer. There's a universal behavior. It's the same in all countries. it's about 4 megajoules per dollar of added GDP. And as a physicist, when you hear that sort of universality, you ask, why is it 4 megajoules? Why isn't it 40 or 0.4? What sets that scale? Is it manufacturing? Is it building houses? Is it cooking? Whatever. And so I've sort of set myself the task of trying to understand the 4. And if you could understand it, maybe you can modulate future energy demand, because most of the growth in the energy demand over the next 30 or 40 years is as those countries develop, they're going to need more energy. So that's one of the things that's on my mind at the moment.
Do you have a sense of what that 4 comes from? Is it mostly
No, not yet.
transportation? Interesting.
Not yet. Not yet. Manufacturing, maybe. I
Hmm.
mean, so look at the manufacturing output and see if it grows in the same way. But that's why it's research.
Very cool.
Another thing that is occupying me again on a research sense is we hear a lot about the benefits of net zero,
Mm.
but we don't hear much about the costs. And there are several independent estimates of the costs that differ among themselves. And I would like to, by convening the estimators, try to get some reconciliation of the different estimates.
And the
I
cost
can
to
tell
who,
you,
right? The cost to
well,
who
society,
exactly?
how much do you have to build? How much transmission line do you have to build? How much generating capacity do you need? How much cobalt do you need for the batteries? And people try to make estimates of all of that. Somebody will have to pay the cost, of course, but we're kind of silent on who the payer is. It's just how much is it going to cost? And I can tell you, at least for warmings up to 3 or 4 degrees, the estimated impact on the GDP is a few percent, but the estimated cost is 3 or 4 times higher.
Hmm.
So on a strict cost benefit analysis, net zero by 2050 really doesn't look like a winner.
I mean, I saw a really crazy proposal from some UK institute that was associated with Oxford. I think it was like the Fires report, where they went through what needed to happen in order to
Yeah.
achieve net zero. And it kind of chilled my blood, because they were like, no flights, no trains, no drives more than 10 kilometers, no transportation of goods more than, I think, 50 kilometers. And it was just item
Very
after item.
soon too, right?
By I think like 2050, they need to get it to
But it
that
was like a
point.
stepwise project
Right.
of how they were going
So,
to
so,
scale these things back.
so yeah, that just ain't going to happen. All right, you could just not going to happen.
I mean, that's a relief, because I feel like I worry about how much fear, uncertainty, and doubt is circling around the question of climate, and the intensity of the voices that say that we have to get to net zero, and the ways in which that feels like it is driving crazy decision making. Because I watched it during the beginning stages of COVID too, where there was a couple of reports that were saying, if massive mitigation strategies weren't put into place, that there would be, 15 million deaths. And I think that these sorts of reports drive massive fear and overreaction. And so if somebody's sitting there and is like, we're all going to die by 2050 if we don't get to net zero, then people are willing to jump on board with decision. Maybe they're willing to say, fine, no trucking, no flights, no travel.
That's why you see me, but maybe more importantly, many other people like me who are trying to bring some reality and fact to this discussion. Because when you read the official reports, they don't say anything of the sort, that so many millions of people are going to die and so on. Yeah.
I really appreciate you taking the time. It's obvious how much passion you have for the subject, and how much experience you have on all sides of these questions, from the scientific to the political. And
Yeah.
I really value your insights.
Thank you. One dimension I don't propose that we cover it now, but it's something you might think about for a future discussion with somebody else, not with me, is the downsides of speaking out,
Hmm.
supported speaking out. I mean, here are the facts, here's the data, and so on. What the cost is of that in one's reputation, career, and so on. Pilkey might be particularly good to talk about that. If you look up his history, you'll see why.
And did you
And
have a lot of
again,
pushback?
if you cut this part out,
Hmm.
so I'm just about to move to Hoover, and take up a full-time position there. I have friends on the Stanford campus who don't run away from me. So I think they're willing to engage, but I think that's more because it's me than if I'd been somebody else, it might have been different.
That helps.
Right. Very good.
Thank you so much.
Have a great rest of your day.
Thank you. Okay. Bye-bye.
Take care.